Hi everyone, welcome you all. Today we are going to look what are queues and how to implement these queues in Python list. Okay, and then we are going to see some of the application areas where queue can be implemented or queue can be used in computer world. Okay, so let's get started without any delay. So first of all, we are going to see the definition for queue. A queue is a linear data structure which is based on the principle of first in, first out, where the data entered first will be accessed first. It is built using the array structure and has operations which can be performed from both ends of the queue, that is head dash tail or front dash back. Okay, operations such as adding and deleting elements are called in queue or insert operation and dequeue oblique delete operation, and accessing the element can be performed. Queues are used as network buffers for traffic congestion management, used in operating system for job scheduling and many more. Okay, now here the term what is job scheduling, you can think of a situation where we have many jobs of printing and we have only one printer, so all the jobs will be performed one by one on first come first out basis. Okay, here in this example you can see we have a ticket counter and persons are standing in the queue. Okay, so first element or a first man will do his work first, and then second, then third, then fourth. Okay, right, so this is called a queue. Now let us see and understand queue using the animation. Okay, so here is an ADM. Okay, and this will be called a front end and this will be called a rear end or tail end. Okay, so now first element comes, so this is called in queue and first element stand in front. Okay, then second one comes at the rear end or from the tail end. Okay, now third man, woman, whatever comes in and joins the queue at the rear end. Okay, now suppose if I want to delete an element or my first guy has finished his job, taken out money, and then okay, so here from this position from front end object is deleted or element is deleted. Okay, so now what here, your front pointer will move one step ahead, and or you can say it will be incremented by 1. The next is a new element comes in and same from the rear end, and this will increase the rear pointer by 1. Okay, now one more element comes in, so you can see this guy also joins the queue at the rear end. Nobody can break the queue. Okay, now this process is continued till the end. Okay, so let us see the next slide. Now here we have tried to implement our queue using array, you can say that. So first of all we have taken an empty list. This is, you can see, an empty list. Then in the next step we have initialized both rear and front end to the -1 so that none of the element can be accessed using the list. Okay, the idea is we are going to traverse a list from front end to rear end. Okay, so obviously -1 to -1 we are not going to traverse a single element, so this will demonstrate an empty list. Okay, once the queue is created we will perform a various operation on it. For example, we are going to insert element, we can traverse it, or we can delete the element. Okay, so here what we are going to do for the first operation, that is we are going to insert the element, that is 5. Okay, so 5 will go to the 5 and both the pointer will be initialized to 1 for the first element only. Okay, and for example I am going to insert one more element. In this case here we are going to insert a 5, then your only rear pointer is increased. Okay, remember in the previous example when front is equals to -1 and rear is equals to -1, when we have inserted the element, both the ends front and rear were increased. But after the first element is inserted or if the rear value is not -1, then only rear pointer is increased. Okay, now the next is we are gonna delete the element. In this case, your front end will be increased. Okay, so you can say that one element has gone, now front is equals to the rear. Okay, now insert, rear is increased. For insert, rear is increased. For deletion, front is increased. For deletion, front is increased. Okay, now if you further delete it, your front and rear should be initialized to -1. Okay, which will again utilize your complete list. Okay, so let us see an algorithm so that we can implement insertion operation on the list. So here, first of all, we are gonna start. Then step 2 is check front and rear values. If both the values are -1, then obviously we need to increase both the rear and front by 1. Otherwise, rear is incremented by 1 till element, or if you have cap of size, you can check the size. Okay, I'm not going to do it here. Step, add element at the rear. Okay, this is called enqueue. Enqueue rear is equals to new element, whatever it is, and then stop. Okay, so this is real simple. Now let us check what will be the steps for deletion. Okay, to delete, first of all, we have to check whether the situation is underflow or not, or front is equals to -1 or not. That means there is no more element to be deleted. Okay, if it is not there, then you have to delete an item. Delete item is equals to q dot front. If the front is equals to rear, then front is equals to rear is equals to -1, or we are going to reinitialize the q. And finally, previous situations are not true, then we are going to just increase the value for front. Okay, and this is optional step which can say print item deleted. Okay, in this way we are going to implement a delete operation. Okay, so now let us move how to traverse through the list. Okay, to display the list, we are going to start first. Store front value in a temporary variable called I. Check I position value. If I value is -1, go to the step 4, else go to the step 5. Okay, so step 4 says print q is empty, right? And go to the step 8, stop, right? If it is not, then the condition, that is I is not equals to -1, then you have to print the q element and then increment the value of I. Okay, now in this step we are going to, in step 7 we are going to check whether the value of I is equals to rear +1, and if it is, then we have to go to the step 8. Otherwise we have to repeat the step 5. Okay, so finally one by one we will print all the element from our front to rear. Okay, so this is all about the algorithm. So this concludes today's topic, and next day we are going to discuss how to implement q in Python using a list. Okay, so goodbye and have a nice day.